Good morning, everyone. Today we're going to continue our discussion on panel data regression. We'll have a review first of the fixed effect and random effects in panel data regression. As you all know, we have three methods: the pooled OLS, fixed effect, and random effects. Of all of these three, okay, the quote-unquote weakest form of panel data is pooled OLS. There are certain assumptions that's done in pooled OLS, which makes it the quote unquote the weakest or the worst type of panel data regression. And usually, if there are really specific individual effects, then the better model should be your fixed effect or your random effects. Okay, let me just go through this quickly. I hope this helps. Okay, I I summarize this so that it will be clear for you. Okay. Yeah, sorry. I think I wrote here the LaTeX code for the fixed effects, but I already gave this to you last time. So I don't think there will be any problem with this because I already wrote the model for fixed effects last time. Okay. Where here you have your alpha sub I, which is for the individual effects. Okay, so let's go through this very quickly. Okay. So it's important that we understand the difference between fixed effect and random effects, FE and RE. Okay, we use fixed effect when we want to control. I'm sorry if I'll be reading through this very quickly. Okay, to guide us. We use fixed effect when it's important for us to control for the differences, individual differences. Now, these differences, they're fixed, they're constant, they do not change over time. For example, culture, okay? Culture and
Sorry, excuse me po, sir. The
yes.
screen it's sharing in
Oh,
Canvas.
sorry. Am I paused? Okay. Sorry. Resume. Sorry. Thank you, James. All right. So this is the notes. May I have your? Okay. Wait. I think there are some messages here. Okay. Sorry, Raul. Thank you. Okay, so may I know, class, if you got let me ask first if you got the Word file. Kindly chat, please. Anybody not having that? It's in Canvas, class. I posted it there. So please, everyone, kindly chat if you were able to access the Word file. Okay, good. Thank you. How about the others, please? Feedback, please. Only three? So let's wait for the others. Maybe they haven't uh, downloaded the file. Okay, thank you. It's in, okay, let me show you. It's in, okay, it's in modules. All materials are in our module section. Here, James, here. Huh? It's not here? What's this? FINARTS, what subject is this? Yeah, K33. Saan yun? Am I looking? Tama ba to? Ang tama. Okay. I don't think, I thought I already posted it. It's not here. Okay, anyway, let me post it. Strange. File, create file, choose file, choose file. Okay. Fixed effect versus random effects. Where did I post it a while ago? Here, class, here. Fixed effect versus random effects. It's not notes on panel data regression, class. It's fixed effect versus random effects. This is different. Okay, this is a new one. This was the one last time. Okay, this is a newer one. Because I'd like for us to review the difference between fixed and random. Okay, now let me again post the question. Do you have the class? Okay, kindly please. Okay, good. Thank you. All right. Okay, thank you so much. Now, class, I hope I'd like to apologize for having to do this. Do what? Just writing the notes and then sharing it with you, because as I said, we are constrained with time. So also the next codes, okay, I'll not leave anything blank, okay, which actually I don't want, but because we're really pressed for time, so I have to do this. So I hope you don't mind me doing that. Okay, is that okay, class? Are you okay with that? I'm not leaving any codes blank because of course, I would want you to type the code on your own and follow along. But as I said, because of time constraints, I hope that's okay. Thank you. How about the comment of others? Okay, salamat ha, salamat. Thank you for understanding, class. Okay, what's important is that you have the notes, you have the codes, and later on, in whatever field, maybe in your thesis or in your corporate life later on, you might be needing these materials. Uh, Maybe perhaps you're going to do a project, etc. Okay, and in the near future, and the most near future, maybe your thesis, maybe you'll be doing a panel data regression, then what we are doing here could be of extreme help to you as you navigate through your paper. Okay, all right, so let's continue now our discussion. So let me flash again let's spend some minutes, class, understanding the fixed effects and the random effects, because understanding and appreciating the difference between these two will really help you appreciate your model. Okay. All right. So fixed effects, you're controlling the individual differences. For example, you're looking at the 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 factors that affect stock returns, the indices of, let's say, the ASEAN 5 countries. Okay. Now we know that there are differences as far as these Philippines, Malaysia, Thailand, Indonesia, and ASEAN 5, Singapore ba or Singapore. Okay. There are differences as far as these countries are concerned. There are differences as far as, let's say, culture is concerned. There are differences as far as financial behavior is concerned. Okay, so if you're doing panel data, so you have data for several years, several countries, which is panel data, you would like to control for the individual differences. These are attributes or characteristics of these countries that do not change over time. For example, culture, okay, if you're dealing with individuals, for example, you're doing panel data for individuals, for people, then of course, an example of a characteristic that do not change over time is gender, okay, or sex. So male, female, I'm not talking of sex changes here. I'm talking of the regular gender. So let's say 10-year period, whether it was 2010 or 2024, still the same gender. Okay, so we're not talking of other issues here. Okay, so there are certain attributes, whether for a country, for a firm, okay, for an individual that do not change over time. So in fixed effect, we'd like to control that. Okay, these individual differences that do not change over time. But, okay, but this, these qualities may affect the dependent variable. Okay, now we call these differences as unobserved heterogeneity. Okay, now why is this called unobserved heterogeneity? Because it's not part of your data. It's not included in the data. Okay, and as we said, these are fixed for each individual. Okay, I have here an example. Imagine you're analyzing education and income. Okay, you have different countries, and then you'd like to see how education affects income. Okay, so your income is your dependent variable, and your education is your uh, independent variable. Now, countries may have different characteristics like cultural, as I mentioned, geographical advantages. Okay, some countries may be in a position where their location uh, is considered as more favorable compared to another country. Geographical location will not change over time. Okay, now maybe to a certain degree, the population size may remain fairly consistent. We're not talking of changes here in the amounts of thousands, but when you look at population in the millions, it will take quite some time unless there's really population explosion in a certain country. But population may tend to increase relatively uh, constant over time. Okay, or the education system in that particular country. Okay, so these fixed effects, okay, allow us to look at these country-specific differences, and by looking at them as constant or fixed over time, we can dispense with the effect of these country-specific differences on the dependent variable. Okay, so technically, okay, for example, ASEAN 5, when you do a model, Philippines, Malaysia, Indonesia, the ASEAN 5 will have their own intercepts. Okay? When you say intercepts, it's the individual characteristic. And from the regression point of view, we know that the intercept is the value of that particular, of the dependent variable when all the factors, when all the independent variables are equal to 0. Okay? Now, each country gets its own individual intercept in the model. Okay, but we don't directly estimate these intercepts. We control for them. That's why, if you notice, the fixed effect model, does not have an intercept. Okay, let's open once again. While I'm discussing, let's open our model again. Okay, let's go here. Okay, let me just, ito class yung ano natin, no? Yung regression, tapos ito yung fixed effect. This is our fixed effects, okay? The presence of alpha sub I. Okay, where alpha sub I captures the individual specific fixed effects. Okay, so last time, okay, quickly, here's an example. Let me go to the Grunfeld. Okay, this one. Here, class. Okay, make sure that you load again the packages. You turn your computers off. And then is the data loaded here? Yeah, my data is still loaded. Okay. Still here, I didn't erase it. Okay, so my packages are, okay, they're loaded now. And okay, let me view again Grunfeld. So we have your firm, the year, the investment, value, and capital. Now, if we check what type of data this is, okay, I think I have converted it into a panel data. If this is the first time for you to load Grunfeld, then if you take the structure, it should be data frame. But this one I already converted. Okay, so we converted this data. We call it P data, panel data. And we use this function pdata.frame. This is from the PLM package, panel linear model. Okay, sorry, PLM. Okay, and then Grunfeld is our data. Then we have to identify the index for the firm and the year. If the data signified country, then we should name here country. Okay, so the second one is the time. Okay, year. So I will not run this anymore because Grunfeld, I have this panel data already. But if you have closed your computers, okay, or if you have accidentally deleted this, then make sure that you run this. I have P data here. Okay, and I checked the structure a while ago, and it's structure of P data is data frame. Okay, and take note, class, that the index that we used, firm and year, in a panel data, they should be factors. Firm is a factor with 10 levels. And then here, year is a factor. Year is a factor with 20 levels. So you have 10 levels for the firm, 20 levels for the year, giving you 200 observations. Okay? Then you have here your other variables. Okay. Capital is numeric. And then the other one is value. Okay. It's from the P series data, numeric also. All right. Okay, I'm deliberately going over this because I realize I might have been, I was quite fast in my discussion last time. Okay, any questions so far, class? Any questions so far? Could you kindly please chat in the chat box? Clear so far, class? May I have your thumbs up or a yes? If the conversion of your data frame into a panel data is clear. Okay, thank you. How about the others, please? Could you join in the giving the feedback, please? Okay, thank you. All right, then, so the first model class is the pooled OLS. As we said, in the pooled OLS, it disregards the panel data structure, okay, of your data. And the way to run your pooled OLS is use again the PLM function. This is panel linear model. Then this is your dependent variable investment, and we're regressing it on value and capital. These are our predictors, independent variable. Data is equal to P data, and then we have to identify the model, which is pooling. Okay, and then we summarize this, and we take a look at this. All right. So you notice that the output, okay, it disregards the firm level and the year level. So we just have the intercept, the value, and the capital. And as I commented last time, class, uh, this is the pooled OLS is the weakest of the three methods, and it is the most unrealistic because the assumption here is that there are no individual differences. See, country one, country two, country three, they're all the same. Okay? No, no, no attribute, no individual or unique attributes for the countries. So because of that, we're just disregarding. We're just disregarding the firm and the year component. Okay. All right. Then we go to the fixed effects. Okay. I have to rush a bit. So we have this model fixed, and then same thing. Investment is equal to value plus capital. Then data is equal to P data, and then panel. This time it's not pooling, but it's within. So this is for the fixed effect model. Okay. Run. So we have this. Now we're told that we're using a balanced panel, which a balanced panel means that n is equal to 10. You have 10 individuals, 10 units, and they're all present in all the 20 years. Okay, so you have 20-year period, and then you have 10 individuals. Okay, so this is your firm, 10 firms, 10 years. All of the 10 firms are present in all of the 20 years. Okay, that's why it's called balanced panel. And there are 200 observations. Okay, and notice now, wala na intercept, no? No intercept. So what happened here? It controlled for the individual effects. Okay, so that's what we mean by controlling the individual effects, which are considered as fixed over time. Okay, so back to our notes here. So that's what we mean by controlling. Okay, so each country gets its own individual intercept in the model, but we don't directly estimate these intercepts. Okay, we don't do that. We control for them. Okay, but we can check. No? Okay, we can check. If you want to know the individual intercepts, you can do that. I don't think I shared this with you last time. Okay, this one here, I'll chat this. Okay, okay, ito na lang. I also created this object because in the other codes, I used FE underscore model. This is exactly the same as fixed. Okay, so nothing to be surprised about that. Let me share this with you. Let me put it in the chat box. Okay, you may put it under the fixed effects. Okay, so what I did here was to create another model because towards the end I mistakenly used FE underscore model. So just to make sure that I can use this object also, aside from the fixed class. Okay, I also created this. It's the same class. It's the same. Okay, you also regressing, associating investment on value and capital. Data is the same, Grunfeld, and then model is still the same. I just gave it another name. So I won't run that. Okay, but okay, if I want to see the individual intercepts of the 10 countries, we can do this. Okay, we can use the fixed effect. Okay, maybe let's do I have fixed here? I have this, right? FE model. If I view what's inside here, taking some time, but voila. Ito na lang, fix na lang. Tagal yung mag-print. Ha? Why? Nag-register sa inyo class? Nag-print siya? Bakit ayaw mag-print sa akin yung ano? Saan na yan? Here. Let me view this. View. FE underscore. There. Control Enter. Error? Fine. Strange, eh? Ba't nag-error siya? How about in your case, class? Feedback, please. Are you getting this? Are you getting this message, or were you able to print the model itself, the FE model or the fixed model? May I see, class? May I have your comments about this? Were you able to see fixed or FE model? Were you able to get a printout? Hello, class. Kindly chat, please. My question is, if you try to print the fixed object, which is a list of 10, or the FE model, are you able to print it here, or are you getting, in my case, I'm getting an error. Error in is that recursive? So I'm not sure what's the error here. How about you, class? Comment, please. Can print. Okay, thank you, James. How about the others? I think I'm having a problems again with my R. When I began using a different laptop, I began to experience, okay, good. Okay, anyway, that's what's important is that you're able to print it, even if I'm not able to print it. However, we can access that here. Here, class. So you have 10 firms here. Each of these 10 firms have their own characteristics, which means that they will have their own intercepts, okay, which is the average value of their investment, given no value and no data natin, no value and no capital. So if there's no value and no capital, then each of them will have their own intercepts, which means that that is their average value. If their average investment value, if their value is equal to 0 and capital is equal to 0. So we can access that here, class, individual intercepts. If we run this, there you go. Okay, so the average investment for firm 1 is -70, for firm 2 it's 101, firm 5 is 114, -114, etc. Okay, so these are the individual individual intercepts. But in fixed effect model, we disregard this. Okay, we disregard this. So, and that's what we mean by controlling for firm specific effects. Okay, and we said last time that the fixed effect model is more reliable than our pooled OLS. Okay, especially on the condition that the individual effects are correlated with the regressors. Your regressors are your value and your capital. All right. So, how do you know, class, if we're better off using fixed effect and as compared to the pooled effects? So, quick review. We said that we can test There's a test for that. And we did that last time. Again, quick review class. Okay. I think
Okay.
comparing the three models is one class. F test, we'd like to compare pooled OLS and fixed effects. Okay, if you run this, okay, p-value is less than 0.05. Okay, the null hypothesis is that the pooled OLS is the preferred model. Okay, which means that there are no individual effects. But the alternative hypothesis is that there are significant individual effects. So we say that the fixed effect model is more superior to the pooled OLS because there's the presence of there's a presence of individual effects. Okay. So I hope that's clear, class, as far as the testing, the comparison between your fixed and your pooled OLS is. Okay. So we say that we want to control this specific in this what we call unobserved heterogeneity. Okay. This unobserved heterogeneity, which are variables, which are attributes that are not found, that are not recorded. Okay. So when we say we want to control in the context of regression analysis, we mean that we would want what's the keyword here? We would want this is the keyword, isolated. We would want to isolate, okay, or eliminate the effect of these variables, the effect of these individual attributes on the dependent variable. We would like it to be isolated or eliminated. That's what we want to control. Okay, it means to account for the influence of the variable. Why do you want it eliminated? Because we don't want the model to be biased. No? We don't want to bias the relationship between investments and yung value at saka yung capital, because that's what we want to do. Okay, we would want to see the effect of value and capital on investment, and we don't want that the individual heterogeneity of those individual firms to affect the relationship between investment and value and capital. Okay. All right. So I went here to explain, no? When you control for something, you make sure that its impact is taken into account so that it doesn't interfere. Okay? Kasi ang gusto natin, what we want to do is to determine the relationship between your dependent variable investment and value and capital, your independent variables. Okay? So we don't want that the individual characteristics interfere with the analysis of investments and value and capital. Okay, because the presence of these individual characteristics could distort the investment, no? And even the independent variables. Okay, for example, education and income. Okay, we know that age also affects income. Kasi syempre, as far as income is concerned, older people may earn more. So we might need to control for age. Okay, by controlling for age, we're making sure that the relationship between education and income is not biased or is not affected by the effect of age. Okay, so I have here some more notes. Okay, but I think we need to go on. Okay, what happens when you control? You are actually demeaning. So what's demeaning? When you say we demean, we are subtracting the average of each unit from the individual observations. So what will happen is that it will remove the constant individual level effects. Okay, and what's happening with our model, we're not really showing how the computation is being done. But conceptually, yun yung nangyayari. So that's why I said there are no intercepts in the fixed effects model. Okay, however, you can get the individual effects if you want. Okay, okay, I think, and then there's here for the random effects. Okay, I will leave you to read on about this. What's important here is that we understand what's the difference between fixed effect and random effects. And I gave you here some, I think this is quite similar to what I already showed last time. Okay. So you have here, what is the assumption? Okay. For fixed effect, it's constant over time, but for random effects, it's random. Okay. How do we control for the this unobserved heterogeneity? It's by demeaning it. This one, it's considered as part of the epsilon of the error term. Okay. So when do you use fixed effects? When the country-specific or individual-specific factors are correlated with your independent variables. Here, when they're not correlated. Okay, so the difference between efficiency, for fixed effect, it's less efficient but more accurate when these unobserved factors are correlated. So if it's correlated, if these individual factors are correlated with your independent variables, better to use fixed effects. Otherwise, if they're not correlated, then better to use the random effects. Okay. All right. So, okay, so let's go back, class, to our, the purpose of that discussion was to make sure that hopefully you have a grasp of the difference between fixed effect and random effects. Okay. All right. Then how about our random effects? Okay, we ran our random effects last time. Okay, I think this one I'd like to share with you because I added this because in the other section there was also a question about this. Control C. So could you please add this to your random effects? This is more the discussion of theta. Control V. Okay, sorry. I'll put it, I'll remove first the code chunk there, and then Control V. Why? Wait. Okay. So these are additional notes. I placed this after, I think it was in the other section that they had questions about the theta. Okay. So that's for your guidance. Okay, there are still others here. Yeah. This is quite similar to the one before, but anyway, just making sure that you have this. Control C. Saan yung, ito? Exceed na naman. I'll remove the key takeaways. Exceed pa rin. Okay. I'm not sure if this was in your previous notes, but anyway, I'll just provide it here just in case this is not there. Okay. All right. So after you have done pooled, to guide you in your case, after you have done pooled OLS, fixed effect, and random effects, then you'll have to decide based on statistical analysis which is the better model, which is the best model. So we first compared pooled and fixed effects. So I said last time that after you do this, there's actually no more need to do the Bruce-Pagan test. Why is that so? When you compare the fixed and the pooled OLS, it means that there is individual specific effects. So since fixed and random are the same in the sense that they both quote unquote assume that there are individual specific effects, then comparing pooled OLS and random effects become immaterial. Okay, so if the PF test tells you that fixed effect is better, almost always it will tell you that the random effect is better than pooled OLS. So you can either choose to test fixed and pooled OLS or pooled OLS and random. Either way, you get the same result. But it doesn't matter. It doesn't make it worse, class, if you test both. Okay, here I'm going to test again. We did this last time. Okay, what is the null hypothesis here? The null hypothesis is once again similar to the F test, is that there are no, each firm do not have individual specific effects. So similar, class, similar to the PF test. So here we reject the null hypothesis that there are no significant effects. Okay, individual significant effects based on the Bruce-Pagan test. Okay, so as expected, it told us that the fixed effect and the random effects is the preferred model compared to the pooled OLS. Okay. All right, and the last test is the Hausman test. Okay, here we are testing if the individual effects are correlated with the independent variables. If they're correlated, we say that the fixed effect is a better choice. It's the more efficient choice. If the individual effects are uncorrelated with the individual variables, independent variables, then the random effects is a better choice. So the null hypothesis here is that the the individual effects are not correlated with the independent variables. Okay, so we use the Hausman test. This is from we use the function pH test, and then we compare fixed and random, and then if we print the output, let's print the output. Okay, so here's the Hausman test, and the p-value is 0.3, which is greater than 0.05. Therefore, okay, what's our conclusion here? What's our inference? We fail to reject the null hypothesis that that the individual effects are uncorrelated with the independent variables. Okay, so we fail to reject that. So therefore, since p-value is 0.3, the random effects is better. Okay, so p-value greater than 0.05, random effects is preferred since individual effects are uncorrelated with regressors. Otherwise, it will be fixed effects. Okay, let me pause for a while, class, and once again ask for your feedback if so far the process of determining whether it should be pooled or fixed or random effects and their differences is clear so far. May I request for your feedback? Feedback, please, class. Okay, thank you. Waiting for the others. Okay, thank you. Thank you. All right, good. So, since we have generated the pooled fixed effect and random effects, and we have determined that random effects is the preferred model because the individual effects are not correlated with the independent variables, then we analyze the random effects. And we will test for heteroskedasticity, test for autocorrelation, and test for serial correlation. Okay. All right. So last time we did this. Okay. So I'll just quickly review this so that we were able to go to the FGLS. Okay. So we're using the Bruce-Pagan test here, test for heteroskedasticity. And then this is the code: investments associated with value and capital, data is P data, studentized is equal to false. Okay, this is the residuals if the residuals are converted into normalized data. Okay, we ran this last time and okay, the null hypothesis is that the residuals are constant and the p-value being way below 0.05, we reject the hypothesis of homoscedasticity. Okay, so number one, diagnostic, the residuals are heteroscedastic. Okay, second class. Second test is the test for serial correlation. Now, there are two types of serial correlation. Test for serial correlation can be the Wooldridge test, and the Wooldridge test is used when you're dealing with fixed effects, okay? But when you're dealing with random effects, this will not run itong Wooldridge, which I gave you here below. Ito class, no? This will not run if you're dealing with random effects, but this will run. Okay, the Baltagi and Lee. Okay, so panel Baltagi and Lee test, random. And if we run this, okay, so we're getting this. No? And the p-value is once again way below 2.05. And the null hypothesis, by the way, here is that there is, okay, wait, let me put here, null hypothesis. Let's correct this. There is no serial correlation, okay, in the residuals, okay? So no serial correlation in the residuals. And the p-value is less than 0.05, okay? Therefore, we're saying that there is serial correlation, okay? All right. If the p-value is less than 0.05, then serial correlation is present. All right. Now, I think I gave this to you, no? If only heteroscedasticity exists, then we can use RE with robust standard errors. I'll explain this now. Okay, if only there's serial correlation, then we can use random effects with clustered standard errors. If both issues exist, my heteroscedasticity and there's serial correlation, then one alternative is to switch to feasible generalized least squares. Okay, there's another method which I'm going to discuss in a while, but for your paper, I want you to do this, okay? I want you to do this because oftentimes panel data would generate both serial correlation and also heteroscedastic residual distribution. Okay, so we go here. Okay, the third test is test for cross-sectional dependence. Did I give this to you, class? Could you please tell me if this is in your notes? Kindly chat, please. Is this in your notes? The purpose of the Pesaran cross-sectional dependence test? Matagal klase yung reply. Anyway, in case you don't have it, all right. So this is the third test, class. CD test. Pesaran CD test. Okay, so what is this for? What is this for, class? It will check. Cross-sectional means it's the relationship between your units. In this case, firms, firm 1, firm 2, firm 3, etc. And it will test whether the residuals, okay, across the different cross-sectional units, the firms, are correlated. So are the residuals of unit 1, firm 2, firm 3, firm 4, are they correlated? Okay. It will test if the firms influence each other in ways that are not captured by the model. Because if the residuals are correlated cross-sectionally, for example, correlated yung residuals ni firm 1 and firm 2, then that means that they're not independent of each other. The firms are influencing each other. Okay? If the residuals are independent across firms, then each firm's investment is driven only by its own factors. So this is a very important aspect. If there's no cross-sectional correlation, then it means that each firm, the investment of each firm, is only driven by its own independent value and capital. Okay, it's not driven by the value and capital of the other firms. If the residuals are correlated across firms, then there's a suggestion that there may be a spillover. What do you mean by spillover? Okay, what's happening in one company is quote unquote shocking, no? Sinashock din niya, nakaka-affect din siya dun sa in what's happening with the other firms, and it's called spillover effects. Okay, and there are many papers doing this, no? Spillover effects. So spillover effects are shocks, economic shocks affecting all firms, industry-wide trends or network effects. Okay. Now, why is this important, class random effects model? Because there's this assumption that firm-specific effects are independent across firms. So that's an assumption in random effects model. So that's why it's important to test yung cross-sectional dependence. Kasi if that fails, then our assumption in RE that the firm-specific effects they do not affect the other firms, then we cannot, we're violating that assumption. Okay, and what happens if there's a cross-sectional dependence? Then our model may be misspecified. Okay, it means that the error terms, the residuals of each of the firms are dependent, and therefore our RE model may be misspecified. Correlated kasi mga residuals eh. And it violates the assumption of this one, yung independent. No? Independent yung mga firm-specific effects. And what does that lead to? May bias yung model natin. Okay? So may bias yung model natin. All right, so this is the test class. Okay? Pasaran, or it can be panel, cross-sectional dependence test. Okay? Wait. Dali lang ha. Bakit fix ang ginamit ko dito? Let's test class. All right? So, okay. So the p-value is much lower than 0.05, and the null hypothesis is that there's no cross-sectional dependence. Okay, now I'm using fix here. Okay, let me check. Kamali lang ba ako dyan? Test yung random natin class. There. Okay, sorry, I made a mistake here. Okay, so it should be random. Okay, and then the p-values are quite different, but they both say that whether it's fixed or random, there's cross-sectional dependence. All right. So here, I think you have this, right? Yung stargazer natin class. Kindly quick comment class if you have this. Yeah, I think I gave this. Okay, anyway, we can run this and then we can see the comparison between these three. Okay. Let me rerun this. Here. One is your pooled. Two, sorry, it did not. I wanted to. I should have used a lower, smaller font in order to compress. But anyway, those are the summaries using Stargazer. Okay. Now, okay, this one. Okay, this one, I don't think I gave this. So let me quickly. Okay. I guess I'll have to, class, I have to use another Word file for this. Okay. Yeah, I think this is quite long. All right, class, what I'm going to do is I'm going to create another Word file and share this with you. Now, let me just explain what this is, class. So suppose you have your residuals are heteroskedastic. This is for FE model, sorry. So I'm going to share that also. So let's go here. How do you address heteroskedasticity, class? How do you cure this? Okay, good thing now is that we can use robust standard errors. If only the issue is the heteroskedasticity of your residuals, then that can be easily addressed by, okay, using this Control C, Control V. Okay, it's already time. Ako, wala pa tayong ano. Okay, time na, no?